Hello there, once again, our esteemed viewers on this favorite mathematics YouTube channel, Mathematics by Abu Zainab. The channel is specially curated for you and I to come together to demystify mathematics and tackle the age-long phobia associated with this subject, one topic at a time. From our last lesson, we have been delving into the topic indices. And today, which promises to be exciting and interesting and quite revealing as well, we are going even deeper into the topic indices. This time around, we are looking at indicial or exponential equation. As the name implies, indicial equation is a fusion of two topics, really. That is indices and equations. However, indicial equation is possible to lead to three categories of equations. From indicial equation, you can have linear equations, you can have simultaneous linear equations, and you can also have quadratic equation. However, the focus of our lesson today is to deal with indicial equations leading to simple linear equations. Come along as we delve into the beautiful world of mathematics. So, to help us to this class, we are looking at these four examples of indicial equations. So, let's start. Number one, we've got 9 raised to power y equals 27 raised to power y over 3. The summary of solving simple linear equations resulting from indicial equation is that we are going to aim to have equal bases or equal indices, as the case might be. For this question now, we have 9 and 27. They are clearly not the same base. However, if you look in depth, we can simplify them to have the same base, which is number 3. Hence, 9 can be written as 3 to the power of 2. Then we still have our y. And 27 is 3 to the power of 3. Then to the power of y plus 3. Hence, I've written 9 as 3 squared, 27 as 3 cubed. The y and y plus 3 remain. The next step is to open the bracket. That is 3 raised to power 2y equals 3 raised to power. Don't forget, this 3 here multiplies everything here. So it's going to become 3y plus 9. So the aim has been achieved, which is to have the same base, 3. So we simply equate the powers. So 2y equals 3y plus 9. And simplifying this simple equation by collecting like terms, we have 2y minus 3y, which equals 9. And this is minus y equals 9. And dividing both sides by minus 1, which is the coefficient of y here, I'm going to have y equals to minus 9. It's as simple as that. I believe you find that quite interesting and simple. Let's move on to number 2. For question number 2, you have 4 to the power of y minus 3 equals 1024. In this case, we have y and 1024. We may not be able to think instantaneously of equating 4 and 1024 to the same base of 4. However, we can go easily by the route of base 2, because 4 can be written as base 2. Similarly, 1024. So we have 2 to the power of 2, that is 4. Then we have our y minus 3 retained, equals 2 to the power of 10. That is 1024. So again, here we have, opening the bracket here, 2y minus 6. Don't forget, we are multiplying the 2 with y minus 3. So the 2 affects both the y and the minus 3. Just like this, again, we are having the same base of 2 in this case. So pretty much the same, we just equate the powers. So 2y minus 6 equals to 10. And by simplifying this resulting equation, I'm going to have 2y equals 10 plus 6, giving us 2y equals 16. And divide both sides by y by 2, y then is 8. It's pretty simple, if you ask me. I believe you found it quite interesting and very, very straightforward. If that, let's move on to question number 3. Question number 3 is slightly different from 1 and 2, in the sense that the unknown or variable is actually the base in this case. So there's no way we can simply equate y to 16. Rather, we try to tackle from the index. The clue here is to use the reciprocal of the index to multiply the powers of both sides. What do I mean? The index here is minus 2/3, and its reciprocal which also means inverse. It's simply switching roles. Numerator becomes the denominator and denominator becomes numerator. Of course, maintaining the negative. So we having minus 3 over 2 as the reciprocal of minus 2 third. I do the same to the left right hand side. Meaning I multiply both right hand side and left hand side index with minus 3 over 2, which is the reciprocal of minus 2 third here. The aim is to eradicate the power here to make everything 1. How so? Minus times minus plus. 2 third times 3 over 2 is actually going to be 1. So we are left with just 1. Y raised to power 1, which is our desire anyway. Equals 16 raised to power minus 3 over 2. Then you are left with this, which we did quite earlier in our lessons on indices, where I said that the denominator of this rational index will determine what happens to the 16 here. So here we are going to have 4 raised to power 2, which is the denominator here, minus 3 over 2. So that this 2 cancels this 2. We are left with 4 raised to power minus 3. And again, by the law of indices, from our previous lessons, we have 1 over 4 to the power of 3. Hence, our answer is 1 over 64, which is 4 times 4 times 4. I believe you found this a bit interesting as well, though might be seemingly technical. But trust me, when you lay your hand on a lot of questions, you find it pretty easy and smooth. And that leaves us with the last question there. The last question, number 4, we've got 5y equals 40y to the power of minus half. Okay, this question is peculiar in the sense that we have products on both sides. So the very first thing we do is to try to write them in indices form, strictly indices. So by so doing, let's divide both sides by 5. So I'm going to have 5y over 5 is equals to 40 over 5 y minus half. Hence, we have just here y equals to 8 y minus half. The next thing is to divide both sides by y power minus half. So we have letters on one side and numbers on the other. So I'm going to have y divided by y raised to power minus half equals to 8. And by simplifying further by indices, this is 1 plus half. From the first law of indices, the laws of indices in our previous lessons, this power 1 here, that's 1. Division is minus. Then when this minus goes up, minus times minus becomes plus, equals 8. So we have what here? Y to the power of 3 over 2, which is 1 plus half, equals to 8. This is our basic. So, solving further, we have y to the power of 3 over 2 equals 8. Just like I mentioned in the previous lesson, that we are going to deal with the power. So here, the power here is 3 over 2. How do we eradicate it? By using the reciprocal, which is 2 over 3. Equals similarly 2 over 3. Don't forget, whatever you did to the left-hand side must also be done to the right-hand side. So when we multiply the powers, that reduces y to just power 1. And again, just like we had here, this should be 2 to the power of 3. And what necessitated that is the denominator 3 here. So 2 power 3 gives us 8 really. Why 3? Because of the 3 here. So that the 3 cancels 3 and y equals 2 to the power of 2. Hence, y equals to 4. That's pretty much the solution to that question. I believe you found that quite interesting, revealing, engaging, and fun, most importantly. And that's the end of our lesson for today, which is exponential or initial equations, leading to simple linear equations. If you find our lesson really interesting, please do well to stay tuned by subscribing and put on your notification bell so that you'll be the first to know when the next lesson drops. Thank you and stay blessed.